All right, so we're going to finish up 9.3, our section over geometric sequences. I think this one's going to be pretty quick. So I teased that we were going to have another type of mean other than the arithmetic mean. So here that is, the geometric mean. So just in general, two numbers, x and y, have a geometric mean of plus or minus the square root of x times y. So this is kind of like a multiplicative mean, whereas we have the arithmetic mean where we add them together and divide by 2 for two numbers. Here we multiply them together and take the square root. And again, this is useful because in a geometric sequence, any term is the geometric mean of the two terms around it. So that can be useful in finding a missing term if we can't guess what the pattern is. So quickly in example 4, find the missing term in the geometric sequence. So if this is geometric, that means the pattern is multiplying by a common ratio. So we have 27 blank and then 243. So typically this might be kind of difficult to guess and check what the pattern may be. So we want to have this way that we can just solve for the middle term. And that is by taking the geometric mean, which is plus or minus the square root of the product of the two terms around it, 27 times 243. So if we want, we can figure out what that 227 times 243 is. It is 6,561. So this is plus or minus the square root of 6,561. And the square root of that is 81. So we want plus or minus 81 here. And that says that there are two possible numbers that could go in the middle of these two numbers in this pattern, positive or negative 81. So you want to make sure, unless you can tell what the number definitively should be between those two, then you want that plus or minus sign just in case. So you can see if the pattern is, let's say, multiplying by 3, 27 times 3 would give us 81. If we multiply it by 3 again, we get 243. Or we could have 27 times negative 3, which would give me the negative 81 in the middle. But multiplying that by negative 3 would make it positive again, and we would get positive 243 once more. So there are two different possible patterns here, multiplying by 3 or negative 3, which is why we get those two numbers in the middle. All right, and then one last example, and then we'll be finished up for this section and for this chapter. That's all I'm going to do on here. So here's a potential ACT question. How many terms are there between 13 over 16 and 208, exclusive of 13 over 16 and 208 in the geometric sequence 13 over 16, 13 over 8, 13 over 4, and so on until we get to 208. So what I would do here is try to list out all of the numbers in between. So of course, we know that we have a 13 over 16 followed by 13 over 8 and 13 over 4. And then we want to keep this pattern going. And again, we know it's geometric, so we were multiplying by something. You may be able to see a little bit of a pattern here. Some people may say we're dividing the denominator by 2, and that is kind of correct. But that gets confusing once we start to get into the whole numbers. So I would want to try to figure out a better way to say this instead of dividing the denominator by 2. So there are a few different ways that you can look at it. But another thing, what we usually try to do, if it's geometric, I'm multiplying 13 over 16 by some number to get 13 over 8. So let's reverse that. What is 13 over 8 divided by 13 over 16? So 13 over 8 divided by 13 over 16. And that is 2. So we're multiplying by 2 each time. So we have, let's double check that. It looks like we have a ratio of 2. So if I start with 13 over 16, and I multiply that by 2, I get 13 over 8. Then I get 13 over 4. Next comes 13 over 2. And then we can maybe see the next one would be 13 over 1, which is just 13. And then we would get 26, 52, 104, and 208. So then we want to look here and make sure we're answering the question, how many terms are there between 13 over 16 and 208, exclusive of those two numbers? So that means, when we are counting up the terms in between, we do not count 13 over 16 or 208. So how many terms are here? 1, 2, 3, 4, 5, 6, 7. Count that one more time. 1, 2, 3, 4, 5, 6, 7. Perfect. So there are 7 terms in between the two listed terms here. We just had to work it all the way out and list all of the terms from 13 over 16 to 208 and count them up.